Hello, Precalculus student. This video is for chapter 3.6 part 1, zeros of polynomial functions. We are going to deal with some polynomial that's very difficult to factor by, all the skill that we use like GCF or difference of two square or diamond. None of them work, or even substitution. It doesn't help, but we know that it is factorable. It does have a linear factor. So how do we deal with those, finding the linear factor? So we have two theorems that let us help us to understand it. The first is nothing to do with zeros, but it's kind of like the theorem behind the idea of using divisions to find a factor. Okay, so if I have a polynomial f of x, right, and I want to find f of k is a number, so that would be plug in, right? For example, just like this example, find f of 2 if f of x is equal to 6x4 minus x cubed minus blah, blah, blah. So what you do is you just plug in 2 to all the x's, and then get a number. So it's nothing to do with division, nothing to do with solving. It's actually just plug in. So what happened is this remainder theorem say, well, if you divide, now k is what you want to plug in, but if you divide the same polynomial by x minus k, the remainder is actually f of k. How do I prove it? So the book talks about it, but I'm going to prove it really quickly. So just for example, if you do divide by x minus k, right? So remember, you do those long division and stuff. You're supposed to have a quotient of x plus a remainder over x minus k. Remember, that's what we did. That's what we do in the last chapter. You divide something that is a quotient, I call it q of x for that. Now, if I multiply both sides by x minus k, so I would have f of x, so there's not enough space. So this is what we know. Divided by x minus k, we can divide it, and it is equal to the quotient plus the remainder over x minus k. And so if I multiply both sides by x minus k, assuming that x is not equal to k, we just multiply both sides. So f of x would equal to q of x times x minus k plus r. Does that make sense? So this works for x minus k. And then we plug in, and then we would just say, let's do f of k. So if you plug in both sides, so this side is f of k, this side would be 0 times q of x, and that would be the r. So this is exactly the remainder that you did if you do a long division. So it's very strange. Usually we would just do plug in, but what the remainder theorem tells us is you can actually just do a long division and find the remainder. That is as if you are plugging in. For example, I want to find f of 2. So I don't want to plug in because this polynomial is really long, but I can do a division of x minus 2. So that means I'm going to divide by x minus 2. Okay, so this is the explanation on those. So let's divide x minus 2. So I would have 6, negative 1, negative 15. Do I skip anything? 4, 3, 2, 1, 2, negative 7. I want to divide it by negative 2, so that would be 2. Bring down 6, so 2 times 6 is 12. 12 plus negative 1 is 11. Times 2 is 22. Add negative 15 is 7. 2 times 7 is 14 and 16. 16 times 2 is 32. And then 32 minus 7 is 25. So we're not interested in the quotient, but we're interested in the last number because that is actually f of 2. Whatever that you're dividing, that is f of 2. So that's quicker than you plug in so many times, right? So that's called the remainder theorem. The second is the factor theorem. Factor theorem say what? K is a zero of f of x if and only if x minus k is a factor of f of x. That makes sense, right? So if you can write f of x as x minus k times another factor, let's say um, um, factor f of x, big F of x, right? So of course this is 0 because when you plug in k, when you plug in x equal to k, this side is 0. So a 0 is when f of x is equal to 0. So this is a 0. And you so f of k is equal to 0 because when we plug in this side. But what does f of k equal to 0 means? That is when you divide f of x by x minus k, according to the remainder theorem, the remainder is 0, right? So if you look for, when you do a synthetic division of x minus k for f of x, the last column in the remainder field is 0. That means you find a factor of x minus k. So do an example. I want to show that x plus 2 is a factor. So I don't have to divide it. I have to just, I divide it by syntax. Of course, I can just plug in, right? Plug in x equal to -2 to see it is 0. If it is 0, then I know that, oh, f of -2 is 0, so x plus 2 is a factor. But I can also do a synthetic division, 1, -6, -1, 30. And I'm going to divide by x plus 2. That means -2 because we always divide by x minus k. Okay, we divide by this. And then, so you put down 1, -2, -2 times, plus -6 is -8, and 16 plus -1 is 15. 15 times -2 is -30. It is 0. So you have a remainder 0. So that means, yes, x plus 2 is a factor. And what is the other factor? The other factor is right here in the quotient. The other factor is, so this is 1, so we do it like this. 1 x squared minus 8x plus 15. So this is the other factor. You factor all of them, and very often after you find the first factor, the second becomes quadratic. You can use quadratic scale to solve it. Okay. So, but we are just checking one factor. So check if x minus 2 is a factor. So to check it is x minus 2, I do divide. I think this is x cubed. Okay. So x cubed would be 1, 4, -4, -16. And I divide it by 2. Okay. So bring down 1. 1 times 2 is 2. 6. Add them is 6. 2 times 6 is 12. 12 plus -4 is 8. 2 times 8 is positive 16. You have a 0, right? So that means x minus 2 is a factor. Conclude by the factor theorem. If you divide, have no remainder, it must be a factor. Kind of like, how come 6 is a factor of 18? Because when I divide it, it divided totally. There's no 0 remainder. So we conclude that x minus 2 is a factor. Then what's the other factor? The other factor is in the quotient. The other factor. So synthetic division is very useful. You just move the number as x minus k into here as k, and then you can check. The other factor is this one, 1x and x squared. So be x squared plus 6x plus 8. And then once you find the other factor and this quadratic, you can use quadratic scale to solve it. So that's factor theorem, remainder theorem. It helps to detect if something is a factor. Then you may say, well, there's so many numbers. Where do I figure that? Where do I check? Do I check from 1, 2, 3, 4? Just like, oh, someone asks you, what is the factor of a number? You just keep checking like that. There is a third theorem called rational theorem of rational zero polynomial theorem. So rational zero polynomial theorem say that if your polynomial is has integer coefficient, okay, This has to be a real polynomial with integer coefficient, like 4x cubed plus, like this. So the integer means these are all whole number, not fraction, not radical, like this. Like 3x squared minus 5x plus 1, this kind. That's called coefficient with integer coefficient. Then your rational 0, if it exists, sometimes it may not exist, would have the form of P over Q, where P is the factor of A0 and Q is a factor of AN. That means if you have to have a factor, the factor would be in the top, a factor of the last term, the constant term. Because when we write polynomial, we write it with the highest term first. So this is the leading coefficient. So basically, you just look at the ratio of the two, and then you will say, oh, that's the possible one. If you have the possible one, then you just test them one by one with synthetic until you discover that the remainder is 0. Then you will find a factor. Okay, so let's go over this. Just do an example. What are all possible? Okay, so they might not be rational 0, but they are possible one. So we'll say those are P over Q, where P is plus or minus the A0, rational 0 of -4, factors of -4 over factors of 2. You don't cancel, okay? Factor of -4 is plus or minus 1, plus or minus 2, plus or minus 4. Factors of 2 is plus or minus 1, plus or minus 2. So what are all the possible one? The possible one would be first, you use plus or minus 1, plus or minus 2, plus or minus 4 over 1. And then you do plus or minus 1, plus or minus 2, plus or minus 4 over 2, eliminating all the repeat. So the first dividing by 1 is just plus or minus 1, plus or minus 2, plus or minus 4. So there's 6 that you can try. And then the other one would be plus or minus 1/2 only, right? Because plus or minus 2 over 2 is just 1, which we have written down. Plus or minus 4 over 2 is also plus or minus 2. So these are all the possible ones that you can check. Look at the next one. If f of x is 3x cubed plus 4x squared minus 20x, minus 2x minus 1, what are the possible rational 0? Because all the coefficients are integers. So we would say this is factor of, the top is factor of -1, and then the bottom is factor of 3. So what is factor of 1? It's just plus or minus 1. What's factor of 3? Is plus or minus 1 or plus or minus 3. So totally, all the possible root are what? When you go to divide this by 1 first, that's plus or minus 1, and divide this by 3 is plus or minus 1/3, and that's it. So there are 4 possible ones. Okay, so we are finally going to use the 3 things that we have learned, the remainder theorem, factor theorem, and rational 0 theorem, to find zeros, a polynomial that is difficult to factor. So we'll do it in the second video.